Hello, it's me, John. Happening. Sound is out. That's weird. Test check. Do you hear that? You can't hear me, eh? Hold on. It looks like it's sounding. Maybe now. Oh, someone said it was intermittent. That's even scarier. Let's see. Test, test, check, check. It's back. Hey. All right, I don't know what that was. Sound is now static. No. All right. That's better. Okay. All right. Okay. Is it fully better? This thing's not moving around, is it? We're better now. Yay! So let's take this from the top. Hi, I'm John Park, and we're here for John Park's workshop and audio repair extravaganza as we try to get my mic working collectively. Thanks, everyone. Maybe that was a loose. I didn't have the little door closed. Maybe that was just a loose battery connection. The signals look good on the wireless packs there, so that's good. I suppose I should have a second, like a backup mic. Wouldn't that be a good idea? Fully better, yay. So I was saying, hey, thanks for stopping by, Dave Odessa, Charles Burniford, Connor McCarter, over in our YouTube chat. And the other chat we've got going on here is our Discord. And there I see all sorts of folks, including, hello to, let's scroll all the way up to the top, C. Grover, Paul Cutler, Night Shift, DJ Devin 3. Oh, no, that was from last night. Today, Mike P, hello. Andy Calloway, Blitz City DIY, some nice. That's me with the emojis. DJ Devin 3 with the face hugger, thanks. And Todd Bott, hey. Hello, Sam J. Ohio, howdy. You heard the opening music. Okay, so that was my mic back. Good grief. C. Grover, hello. Hello, everyone. If I missed anyone, sorry. Todd says the time delay is kind of hilarious when I'm trying to debug these problems. Yeah, there's I don't know what, 10 seconds difference between the actual time and when YouTube sends it off into the world. But it looks like we're maybe maybe we've got this all figured out now. So thanks for stopping by. What have we got going on today? I've got a coupon code for you. So you can save some money over in the store if you want to buy some stuff. I've got a recap of the product pick of the week. I've got a CircuitPython Parsec that I think is super snazzy. I have what? Some more MIDI message massage monitor stuff going on. I'll show you a little more in depth some of the demo that I gave last night of this little gizmo here, which is the Feather Reverse TFT SP32 S3 with a MIDI feather wing underneath it there. Since this is a reverse feather wing, we mount that underneath, kind of upside down. Yeah, I'll show you that. Show you some MIDI gizmos going through it and some of the stuff you can do with it. Stuff, more stuff. That's right, Andy Calloway, stuff, more stuff. I also have, I'm not really going to feature this, but I do have, let's zoom in. Let's see if I can get this camera to zoom in over there on the, whoa, that right there, which is my Raspberry Pi. Whoa, look at that. My microphone is trying to sabotage me. Just grabbed the corner. This is the twin stick, tank stick X Arcade that I modified to be that Pico out, and I had it running to my little Raspberry Pi 4 here, and that was headed out of HDMI last time you saw it. Remember a little while ago I did some of the how do you get composite out? Well, I've got composite out now running to this little PVM. So here you can see some Pac-Man running right here. I've been playing a lot of this actually. Enough so that I think it's time to convert over to that four-way joystick so that I can't accidentally do diagonals. I'll be a better player for it. See, look at that. It didn't do what I wanted. I wanted to go right there. So that's been converted over to CRT, and I love it. Looks great. So that's just a minor aside there. That's a thing that's happening. Let me fix this camera now. And let's see. So when I go back over there later, I'm not surprised. Oh, what's Lars doing back there? Don't be so creepy, Lars. Oh, and look, there's my water bottle. I was wondering where that went. Okay, now we're really up and running, huh? Thin Man says, I'm so excited about your doing MIDI stuff. Yeah, Thin Man mentioned at the end of Show and Tell yesterday, I think, that they've got this same little MIDI keyboard here, and they're using it for some music at their church, I think it was, because their organist disappeared. Andy says, lol, like the toothbrush. What toothbrush? Do I have a toothbrush? What toothbrush? I don't know what's going on with the toothbrush. I'm a little scared about the toothbrush. What's happening with that? Who knows? So first of all, I mentioned we've got a coupon code. So if you want to go to the Adafruit store and get some stuff, you can get 10% off today until midnight East Coast time in the US. And that's the coupon code right there, reverse. Reverse will get you 10% off in the store. So head right on over here to the Adafruit store and look at some of the good stuff. There's a toothbrush above the game console. Oh, there is. Yeah, I use that for cleaning stuff. Not my teeth. Yeah, it's on the, no, you're right. It's on the pegboard back there. There is a toothbrush. I don't want to brush my teeth with that one. So that is not ESD safe, by the way. That's just a regular old toothbrush. So the stuff that you can look at in the Adafruit store, just go to adafruit.com, head up to products, look at this little new products drop down. We've got 4 items right there. If you click the little view all there, or pro tip, if you just type in adafruit.com/new, that takes you right to this page. You can see what the latest cool stuff is, including we have this thing, the official Raspberry Pi 5 desktop kit. Raspberry Pi 5 sold separately, but we have those in stock. So you can click a little right there, and now you can hit add to cart, maximum of 2 per customer, and you will get the Raspberry Pi for Beginners Guide, a Pi 5 case, mouse, power supply, USB cable for the keyboard, 2 micro HDMI, is it micro or mini? I forget. Little HDMI to HDMI cables, because you can use 2 monitors with that Raspberry Pi 5, and a 32 gig SD card. So all that right there, if you look, that bundle is $50. You'd get $5 off with the coupon code reverse. Same with your Pi. That's going to be $54 instead of $60. So you can save some money with this coupon code right here. Other neat stuff I saw, we have a little 555 timer breakout on a stemma board, which is pretty dang cool. I'm kind of interested in that. Todd made a comment during Ask an Engineer last night about building yourself a nice little synthesizer using 555 timers, using that, which could be super fun. Plug and play 555 timer synth. What else? This looks interesting. We have these new Cutie Pies, the CH552 chip, which I think you can code it in Arduino. It is not your typical chip that you're going to throw CircuitPython on or anything like that, but it is a super minimal little chip. And look at the price on that, $4.95, because it is such a low-cost chip. What do these cost, like 30 cents or something like that for that chip? It's real cheap. So those are some things that are new. And of course, anything in the store that's a product, you can go to these product categories. You can use that coupon code to get 10% off. It won't work on software or gift certificates or subscriptions, but it's good for physical things you can get in the store. So reverse, that's your coupon code for the day, and you can use that on your way out. During checkout, there is a coupon code slot. Connor McCarter asked, wait, was that a tiny e-paper display? Yeah, so this is the Bear tricolor e-ink display. I believe that'll work with our e-ink breakout and the Think Ink Feather board. So there's a couple of boards that this would slot into. So it's not really a standalone product. That's just the display and the connector. But you can see there we have, this is one of the Feather, Think Ink Feather board. It has a little connector that's specific for that. You can also use this little e-ink breakout friend with that, same connector. So yeah, that's the tricolor display, and as Lady Ada said last night, we thought we were out of these, but she discovered a batch of them, or someone discovered a batch of them on a shelf hidden behind a box of toothbrushes or something like that, and now we've got these available in the store. Must be at least 100, because I think it's at fewer than 100 where you start to see the actual number of an item show up on the product page there. So yeah, tricolor e-ink, that'll do white is one of the colors. White, black, red is the tricolors that you can do with something like that. All right, good. So next up, let's talk about this. I've got this show that happens on Tuesdays, which is the product pick of the week. Here's a little recap from this week's show. The Pico DVI sock and the Pico DVI Pi cowbell. Plug this into the HDMI, and then since I have a little battery in the battery shim there, I can just turn that on. There's the little Max Headroom TV host demo that Phil Burgess did a little while ago, and that is running right off of their tiny little sort of HDMI shank, DVI shank sort of thing. Got the cowbell on a little Pico doubler side by side there. And in fact, I'm running this off of a battery, so you can see the only cables coming out of it, only a singular cable coming out of that right there is the HDMI going through a little micro or a mini HDMI adapter. And if you look behind me there, we've got that Flying Toasters demo. So that's playing right there. So look. Product picks this week, it is the Pico DVI sock and the DVI Pi cowbell. Yes, indeed they were. So if you got yourself some of those, we'd love to see what you do with them. Show us your demos. What are you doing with those little things? I was actually thinking of trying to find the most minimal plug adapter for this. so that I could really shank that one that has a battery right into a TV as I walk by and throw a demo onto there. That'd be kind of fun. As I mentioned, USB, often you've got a USB out on the back of TVs too, so you can make a little nubule that goes on there and displays what you want on a innocent public television, maybe. I don't know. I'm not encouraging you to break the law. All right. Hey, next up, let's do a little CircuitPython Parsec. CircuitPython Parsec. Okay, sorry if there was an echo. I think I left the mic on there. It's always an adventure. Here we go. You can see that code. You can see that little gizmo. What's all these circles? What's happening here? Well, for the CircuitPython Parsec today, I want to show you how you can use a capacitive touch ring inside of CircuitPython. So this one right here is the Touch Wheel 0 that ToddBot has on his Tindy store. I'll put a link in the store there. He sells these for $4, so I don't think he's getting super rich off of them, so I don't mind promoting that. But what you can do with these, I'm going to go ahead and reset this board, is run 3 pins to 3 capacitive touch capable pins on your microcontroller. In this case, I've got a QT RP2040. And then it also has a ground ring. And then there's a couple passives on there. But otherwise, you'll see this acts like a touch wheel, sort of like you'd see on the more modern versions of the iPod, on the iPod after they got rid of the mechanical click wheel. This is simply capacitive touch. And then you can see I'm running out to a NeoPixel ring there, and it's keeping really nice track of my position on this wheel. We can just touch positions on the wheel, or we can glide around it. And what you see over here in CircuitPython is I am setting up Touch I/O library, calling 3 pins here, A1, A2, A3. Then we have a little by checking the percentage of capacitive traces. You can kind of see them there. They're these little Oh no! Someone said we're losing audio again? Oh no. That could be bad. I really hope this mic pack isn't having a problem again. It's transmitting. Check, check. I'm going to unscrew and rescrew in my TRS jack. Okay, I've cranked that in pretty good. I'll restart this demo just so we have a clean one. And I am going to really cross my fingers that I dropped this mic pack. These things are fairly strong. They're meant for, film and video production. But I dropped it. And hopefully I didn't break it because they're not cheap. All right, so I'm going to just vamp for a second here and check the chat to see if that stays good. Really hoping that rescrewing that cable in did the trick. I'm just going to check it on the receiver end as well. I'm getting a lot of reports of it's good, so thank you. Thanks everyone who told me. Literally everyone in our chat was like, hey, yo! So I appreciate it. Okay, it looks like we're good again. I will start, and I'm just going to double check. It doesn't like cut out when I touch this, does it? So I'm just gonna check that it's not any different touching this. That would be like a very weird grounding sort of situation. If we're all still good, I think that was maybe a weird coincidence. Hopefully a weird coincidence, and that doesn't look like it's any difference. Okay, so let's start this all over again. Are we ready? I feel ready. Okay, this one's going to be even better. No, it works, says Starman. Okay, good. I'll take that as a positive. Still good. Here we go. Get ready. I don't have to rerun the music part. I can just jump into this with, all right, get ready for it. For the CircuitPython Parsec today, I wanted to show you how you can use a capacitive touch wheel inside of CircuitPython. So what you'll see I have here, this is a capacitive touch wheel. This is made by ToddBot, and I'll put a link to his Tindy store over in the chat. And what this is 3 sets of copper traces and a few passives, and then we have 3 pins. Those wires are running out to 3 capacitive touch capable pins on my microcontroller, which in this case is a QT RP2040. And what we're doing is reading the position of my finger on that cap touch wheel, and then using that in this case to drive some NeoPixels. But you could use this for anything, as you can imagine, scroll wheel stuff, volume stuff, anything you want that brings in a rotary position you can use this for. This is done actually pretty deceivingly simply inside of CircuitPython. You can see here in my code what I'm doing. I'm importing touch.io library, and then I'm setting 3 pins on the board, A1, 2, and 3, as my touch pins. We instantiate those 3. And then we have this function here. This is called wheel pause, and it brings in 3 values. So the 3 values of capacitive touch on the 3 interleaved copper traces is going to be greater for one and less for another until we cross a threshold, and then the next one rises. If you look in the printouts in my REPL there, you can see we'll get closer to full value on one of them as we're reducing value on the next. And so by checking those percentages that we're touching 1, 2, or the other 2 of those, or just a single one, we get a position along this wheel using some clever math that Todd Kurt wrote. So now if you look in the main loop here, I have my set of LEDs with a little dimming function. We're calling that wheel pause function here to find out the position along the wheel, and then we're setting the main LED position on the NeoPixel ring based on that. And so that is how you can use a capacitive touch wheel using touch.io library inside of CircuitPython. And that is your CircuitPython Parsec.
CircuitPython Parsec.
There we go. I'm back with the audio. That is the little cap touch wheel that Todd has there. This is kind of nice here. You can see the PCB for it, what actually is going on. There's a grid ground trace, ground plane on the back. I think that helps with avoiding capacitive interference. But the main traces of it are these, you can see those little zigzaggy shapes that are the copper traces interleaving them. So you can see, yeah, Todd's got some of these in stock. I'm not getting a commission on these at all. Todd's a good friend of mine. He's charging you $4 for them, so not bad. And you can integrate these into other designs. There are plenty of gizmos out there, especially in the sort of MIDI and synthesizer world, that have these little touch wheels and touch strips. There's a nice one from, is it Bella, the company? Let me look this up. This was the first time I remember seeing it. Bella Synth. I'll show you this here. The Gliss. Gliss is one of them. So these are capacitive touch strips done vertically. Here's their Trill. There we go. The Trill touch sensor. So there's vertical one. There's square. There's a ring. So these are similar ideas. These actually, I think on this one, they're able to detect 5 simultaneous touches, which is a little more sophisticated. But with this sort of simple touch ring, you can get all of the little scroll wheel types of actions you want. Also, there's a hole in the middle here because we don't really need anything. We just need this sort of donut shape to do this. So you could put something in there. Could be a knob in there. Could be an LED indicator. Could probably fit this over a tiny OLED if you want. But there's a lot of neat stuff that you can do with this type of control. So love that. And thanks for Todd for giving me that. I got that free of charge. Woo! Not in exchange for a plug. He didn't know I was going to show that off. So that I have not yet integrated that into MIDI stuff, but I may very well do that. And that is my brief bit of a segue into let's talk about some MIDI stuff. So what you'll see over here, I've got some MIDI keyboards. These are all of this type that, actually 2 of them are of this type that only have MIDI output on them. So you can see there's not a traditional MIDI out, which is a pain when you're trying to interface with older gear. This one here is a slider gizmo that's called, what are these called? Oh gosh, I'm forgetting your name. N16? No, 16N? 16N. This one actually is very versatile. It has MIDI outs and CV outs and all kinds of things, but it'll, since it has a USB MIDI out, I can use it as a little demo of this stuff I want to show as well. And if you look here in the down shooter, let's take a look at this and pull it apart a little bit so you can see better what we've got going on. So this is a reverse TFT ESP32. This is the S3 version. I think it has 4 megs of RAM, 2 megs of PS RAM, something like that. And we've got 3 little user buttons on here. There's a reset button. We have this nice big TFT because it's actually on the bottom. This is the sort of top of the feathers. Over here is the bottom side of it. And then this is, I think I have another one of these. Yeah. So this right here is our Max 3421E USB host Featherwing. So that chip right there is a venerable USB host chip that's used in a lot of products over the years that need to do USB hosting, which is a very specific kind of magic. So that chip can do it. This has been put onto this little Featherwing here, and it has a USB-A port on it, so you can plug things like a mouse, a keyboard, a MIDI controller into it. It will host them and then let you use that data however you like. So recently, the USB MIDI host has been added to CircuitPython library, and you can also do this stuff in Arduino. But getting this into CircuitPython has been pretty cool because it makes it very easy to prototype little MIDI hosting gizmos. So if I give this some power, let me grab my longer USB cable here. You can see it's going to try to find a MIDI device. So that's kind of the first thing it does, is it says looking for a device. And then I've created this little layout here for some of the info that I want to read. So just being able to pick up a MIDI keyboard, plug it in, have it be USB hosted, and find out things like what channel is it broadcasting on. There are 16 possible MIDI channels. What note am I getting out of it? If it's got octave switches on it, what's it trying to send out? What CC knob kind of values is it sending out? We also got pitch bend info on there. So what I'll do is grab this little one right here. This is a really good example because it does not have traditional MIDI coming out. It has to be used with a computer pretty much, or a pretty sophisticated desktop synth. And once we get this thing read into the CircuitPython world, we can write it out as whatever we want. We can use it to control neopixels. We can use it on synthesizers using traditional DIN5 MIDI. We can still sort of use this as a through and go out to USB MIDI hosted software synthesizers. I'll show you a little demo of that. But I've just plugged in this synth here, and you can see it just got detected. It says, oh, this is the MPK Mini 2, which is what it says right there, mostly what it says right there. And I'll go ahead and rearrange camera here so you can see this. Whoa. Okay, it's making noises. That's pretty good. Fix the focus there. So you can see, I just held a note. It's a C. Turns out it's C4, so 4 tells us which octave it is. So I can drop that octave. C3, C2. Some keyboards are actually off by one. There's like MIDI is a little bit messy in some ways. So some keyboards will call their lowest octave 1. Some keyboards will call their lowest octave 0. So that's something that we could use this to adjust to. We could write some code to deal with those kinds of things. So you can see as I'm updating values by twiddling knobs here, those are being displayed. So I see which MIDI number. Each knob can be a different number. And then what value, 0 to 127, is it sending out, which can be useful. And something I demoed on the show and tell last night that's really useful is we can use this gizmo to remap stuff. So a lot of times it's a kind of preset that you don't really want to mess with that your keyboard has. So in this case, this one, this first knob here, by default sends out MIDI CC1, which is, I think, the mod wheel. But I've got it remapped. So you can see there it says, okay, CC1 is what we're reading, but I'm going to write that out to a different channel. So I've remapped that. So you can do all sorts of remapping types of things. We could even potentially remap certain knobs to go out on different MIDI channels. So there's a lot of functionality, utility kind of functionality you can do with something like this. So I wanted to show you how this is actually running in software here. So let's jump over to this code view of the world. Oops, I've got multiple things plugged in still, don't I? Let's unplug the touch wheel. All right. Okay, so the reading of the MIDI is and something I covered in a previous show, but it's mostly done through this USB MIDI importing Max 3421E library and this Adafruit USB host MIDI. I'm also using Winterbloom's small MIDI, so there's loads of different libraries involved here. And I mentioned last night on the show, I'm now also using the Cedar Grove MIDI tools. This is a utility that takes things like a note number and spits out the name. So you can see on my display there, if I focus that. So it's a C sharp, a D sharp. So getting those nice names there, there's a nice little utility in the Cedar Grove MIDI tools for that I'm taking advantage of instead of having to write my own little translator to say the MIDI message, byte stream comes in and it says a number, what does it actually mean in sort of more human musician terms. And then I'm using the TFT display here. This is the board display, setting up some color things here so that I can make little changes to my colors and get these nice little color schemes with dim versions of the values. So that's what these first color dim things are doing. Dexter has a question, can it arpeggiate? So I think that CircuitPython is going to be too slow to make a reliable arpeggiator or sequencer with it, is my guess, especially with the display stuff I'm doing. So at least right now, I would say probably you'd be better off doing it in Arduino if you wanted it to be an arpeggiator. It's not to say it can't be done, but I'm trying to do so many things here that I think we would have problems with timing doing an arpeggiator. But if someone wants to try that or thinks, oh no, you're wrong, you're just going about it wrong, I'd love to hear that or see people come up with their own code for things like this. The other issue, I mentioned this last night and I'll talk about, is that right now the way the USB MIDI host library in CircuitPython is working, it is blocking it's blocking all code while it's waiting for a message. And I have a little workaround that I'll show you that's happening right now, but we're looking to see what we can do so that that's not happening, because that would be a big problem with things like arpeggiators and other timing-based things. So I'm now mostly just using vector I/O to draw lines and dots and text with terminal IO font to display these little bits of info here. You can see I have a little dot here that will change position depending on what thing you're doing. So if I do some CC stuff, or I do some pitch stuff, or if I play a note. So that dot there was just me doing a little bit of a proof of concept of if I'm going to add some UI on here using these 3 buttons so that I can go up to, like, say, the channel line there and then increase or decrease the remap of the channel. That little dot there might be useful. That's why that's there. I don't really need it to tell me the thing I'm doing, but that was just me testing that out. And that's just a vector IO circle, and I'm updating its position as a message comes in of a certain type. So these are all the little text labels, display IO labels that I'm using to do all of the text on screen. And here we go. Here's the setup for our host chip on the Featherwing there. So this is running over SPI. So we have the SPI, the chip select, and the IRQ pins. IRQ pin, after the show, I'm gonna get out my oscilloscope and test to see. This was an idea that Limor had to say to see, does the IRQ pin toggle when a MIDI message comes in? Because that may be a way for me to unblock that read so that the chip can do stuff until it sees that IRQ pin toggle, and then it'll read the message and then go back to doing things like display or knob reading or button reading, that kind of stuff. So we set up this host chip on the SPI. UART is being used right now. I don't have anything plugged into it, but it'll write the MIDI messages out over the TX line, which means we can do I have a MIDI cable here? This kind of DIN5 MIDI is UART, or the TRS cable, like a stereo 3.5 millimeter headphone cable. So that'll be useful for running some of my older synths off of a thing like this. And then we've got some little LED stuff happening. There's a little LED blinking there when a message comes through, just for kicks. And then I'm setting up these button pins here. This is kind of an interesting thing. The buttons, due to some funniness with GPIO pins on the ESP32, one of them is a pull up and the other 2 are pull downs. And so because I wanted to use keypad, the keypad library, I actually have to make 2 different keypad objects because one of them is acting like a pull up and the other's a pull down. So I have 2 of these to read. If anyone knows of a clever way around that, let me know. That'd be cool. But essentially, I set up the first button there on one. Whoops! I'm just calling that my button 0 object for keypad, and then buttons 1 and 2 are on a separate object. They're just called buttons. Now we have this look for MIDI USB device. Let's see if I can make that a little bigger. This is what searches to see if something's plugged in. So it's a little inconsistent right now, but when I restart, you'll see it says looking for a device, and then when I plug it in, it finds that you saw that one said MPK Mini. If I plug this different keyboard in, we should see Arturia key step 32 show up, and these have their own little USB manufacturer codes and names that are read. So plug that one in. Now it says, oh, you're the Arturia key step. I think I might be able to swap it right now, and it'll find the other device. No. Yeah, I don't know why that's being consistent. But even that right there, if you have a fairly confusing cable layout in a studio, being able to just plug things in and see which one that cable runs to is possibly useful even right there if you have a whole bunch of black cables and you don't know which one's to which one. Obviously, you can look and see which one lights up when you plug it in, but this is kind of a little fringe benefit there, so you can see the name of the device that gets plugged in. If a bad device, I don't know what qualifies a bad device, but if a bad device gets plugged in, it'll let you know with this little print here. I just created this little send MIDI panic. So I think during last week's show, you may have seen I had played some notes and one of them got stuck. So I'll do that right now. Okay, so I played 3 notes. I let go of 3 notes. 2 of them sent the proper turn off message. 1 missed it, and I think that's a timing thing or a blocking thing. So I've added this button press which activates that send MIDI panic, but I have to wait until I send 1 more message. That's this blocking issue. So that button press got queued up, but it waits until the read, the message read occurs from the USB MIDI host, then it is able to run that. Better example, and not as annoying because you won't have to listen to that noise there. Let me zoom in a little closer here. I have button 2 here changing my output MIDI channel. So I'm going to press that 1 time. You can see it didn't do anything. It's because it's waiting on a MIDI event. Oh, we've got another stuck note. Oh no. Oh, am I just pressing that? Oh, I'm on the wrong channel now, that's why. Hold on. Oh, I'm never going to get it now. Yeah, I'm on multiple MIDI channels. Darn it. Okay, not a good demo. Let me kill the synth. I'll relaunch the synth. Yeah, I ran into this before. If I'm getting stuck notes and then changing channels, I don't know that I'm able to send the right channel MIDI panic message. So we'll see. We'll see what the solution is to that. But let's see if I can avoid. Yeah, let me just close this. What you may have seen there as I was running through the MIDI channels is if I press this button 2 and then send a message, you can see we just incremented the MIDI channel. If I press this multiple times, 1, 2, 3, 4, 5 times, there are 5 of those queued up. So every time I let it read that what's the name of it? Not keyboard. Sorry, I just lost my mind. Keypad. Those keypad messages get queued up, and so if I press this multiple times, 1, 2, 3 times, now I've got 3, 1, 2, 3 queued up messages for changing that channel. So that's just kind of hacks and workarounds right now, so that I can get the foundational stuff working. Then let's scroll down a little further here in the code. So that's what that MIDI panic is right here. You could do a broader MIDI panic that actually sends the off note for all 127 notes on all 16 MIDI channels. That would definitely just wipe stuff out. Yeah, Max MIDI panic, C. Grover just said over in the chat. All notes in all channels. Yep, MIDI panic, the MIDI panic. I may try that today. So main loop here, you can see it. We do this MIDI USB device equals look for MIDI USB devices. So it runs up, runs this, and then returns what the USB MIDI device is that's plugged in. Then we have a little try except here, which will look for the button presses, and this is dealing with those little buttons on the side there, and then move on to this message equals MIDI device receive. If we get a message, you can see here I'm blinking my little LEDs there, and then I'm checking the type of messages that I'm getting. First of all, if it's a message that's not on a channel, which is MIDI clock, so if you press a sequencer or an arpeggiator button to play on your MIDI keyboard, you'll start getting clock messages which don't actually have a channel to them, so I needed to accept that out of there. If we do have a channel, then I display that up at the top. So another example of this. I can't remember on this keyboard how to change its channel, so you can see why I like having it on the little MIDI massager here. But let me plug in this other keyboard. I'm going to get this out of here. So that's this one here. This one does have an easy-ish interface built right onto it for changing your MIDI channel. The other one probably does too, but it's not as obvious. But here actually you can see on this keyboard these ink silk screen on the top here. This says keyboard MIDI channel. So these are the 16 channels, and you can pick those by holding this Shift key over here. You hold Shift and press one of those buttons, and it'll change the MIDI channel. So let me plug this back in. And so you can see right now it will say that we're receiving Arturia key step 32 on channel 1. If I use Shift and a key here to change it and then press something, you'll see now it's receiving on channel 4. So it can receive on any channel, but right now I'm then remapping whatever incoming channel is, for, in this case 10, out to 1. So pretty helpful. You can also do things, I haven't done this yet, but you could do things like divide up sections of your keyboard, a fairly common thing in MIDI to say, you know what, the lower half of the keyboard is going to be sending out over MIDI channel 2 to a bass synthesizer, and the upper half of the keys are going to send out over channel 4 to a lead synth. So being able to split stuff. Some keyboards have that built in. If this one does, I don't recall, but if it does, you probably have to use a piece of software from Arturia to set that up. But it's the sort of thing that we could do in the little remapper here in CircuitPython without too much trouble. It would just be a matter of portioning off sections of the key numbers and then telling them what channel to send out on. Dave Odessa asks, so much MIDI musical content in your streams, JP, are you in a band? I am not in a band. I don't play any music. I just noodle around a bit for myself. And I just really like the gear. If I'm being honest, it's just fun to get this stuff working. I've helped other people out with questions, people in actual bands, even touring bands, when they have questions on this kind of stuff. So I like to help with that, but I'm not in a band. So let's see. The other messages that we can get here, the message type note on. You can see I'm printing out some info about it. And I'm not using this remap right now, but we could. I showed this last week of being able to maybe make an octave leap or sort of mush this into a particular mode or key. We can filter anything we want, really. It's a lot of filtering and remapping that we can do because of having this little CircuitPython board here. The same thing with CC, and there you see I am, in this case, I'll zoom in, the mod wheel strip. There's a little cap touch strip over here. As I touch that, that is also on channel 1. It's really common for the mod wheels. And it's remapping out to 23, and that's just hard-coded right now. I didn't make a UI for this yet. It's just reading in. If the message type is a CC, continuous controller, we'll ask, what number are you? And this one's going to say, oh, and if your number is 1, then actually, no, it's not. It's 23, and then we send out the message with that new number there. Pitch bend, I'm just reading that and displaying it and not doing anything with it. Channel pressure, this one has channel pressure, so you can see when I play a note, if I, sorry, I'm moving the camera. If I press down harder and softer on the key after activating the note, we get these values of 0 to 127. You can hook that up then in your synthesizer or in your software synthesizer to actually do something with that, so that maybe there's a volume type of thing that you can adjust after the fact, or a filter type of thing that you can adjust after the fact. And That's it. That's all I'm doing with it right now. And then we have some little ways of dealing with if you unplug it. So, oh, it worked that time. Now it's saying looking for device. If I plug one of these other things in, it should see them. I haven't tried this one. Let's find out what happens if we plug in this little 16N. This actually runs off of a Teensy 3.2, I think. So let me steal a MIDI cable from that. The other idea here is that not every MIDI device has a lot of customization in mind, and it may not have a screen on it, and that's fine and it's great. You might not want it, but this could be a useful utility depending on your uses to get a little extra functionality out of a thing without having to go buy a new thing. So let's plug in. I'm curious what it says about this. Okay, its name is the 16N. It found that. And this should just be entirely CC stuff. I'm not remapping any of those values. So there's 72, 73, 74, 106, 107, 108, 9, 85, 86, 87, 88, 67, 7, and 95. I can't remember what I set this up with those particular numbers for. But again, we could go in and force those to remap into something. So, for example, here's CC74. I can just say 74 remaps to 23. Hit save. Okay, and there's 74 coming in. Oh, I have this thing upside down, by the way, looks like. Oh, no, I don't. Okay, so there's 3, and there should be 127. Yeah. So that now brings in message on 74 and sends them out on 23. So there's some little remapping there. Mouse says, wait, was I supposed to write down those numbers? Sorry. Yeah. Okay. So let's see. Yeah, as I mentioned, some of the other things that are kind of interesting about this, I don't know if I have one here, but we have the MIDI Featherwing, which you can put 2 DIN5 MIDI plugs on or 2 TRS 3.5 millimeter stereo cable type of plugs on. And then that would let you run from a USB controller a synthesizer that's just old, doesn't know about USB. I have an example here of this one, which I was just doing a little additional repair on. You may remember this one. This is the one that I got a while ago. It's a Casio CZ101. It's a phase distortion synthesizer. It's from 1983, I think. And it's got DIN5 MIDI on there. This is like right at the dawn of MIDI. Maybe it's from 84. I can't remember. Yeah, it might be 1984. It has a terrible keyboard on it. It's a really clunky little keyboard. So I could take something like this here. Not only does it have a keyboard, but it has a sequencer and an arpeggiator built in. I can run that through the little host there. I'm sort of cheating with this example. That keyboard happens to have real MIDI out, but something like this definitely does not. So if you have something like that made for more of the modern computer era, you could go through this little gizmo and then out with the USB MIDI Feather, which has a proper MIDI out circuit on it, over the UART, over serial TX, and be able to control that gear without having to use the crummy little keyboard on it, which is pretty neat. So let me know if there's any other questions. That's what I've got going on with this right now. We're looking into, when Scott gets back, I think he's going to look into, hopefully, this read blocking issue and what's going on with that. And once I may just turn off some of the MIDI read stuff so that I can work on the interface interactively, so my buttons actually move without having to press a MIDI thing. So once I get that up and running, it'll be I'll be able to do more kind of on-screen adjustment of things to do filtering and remapping, which is kind of the fun stuff there. I think that's it. So if there's no other thoughts or questions, I will wrap it up. Thanks everyone for stopping by today. Thanks for putting up with my audio issues. I am hopeful that it's actually working now, and just tightening that headphone cable did the trick. Cross fingers. Okay. Once again, I'll remind you, if you want to get some cool stuff in the store, I think you can get these. If we look at Max 3421E, this is the host Featherwing. We also have a USB host BFF for CircuitPy, so you could use it in almost an identical way on a CircuitPy. Really small little nub thing. Maybe you're not using a display on it. Maybe you're running it out to a little separate OLED over I2C or something like that. But this is the Feather USB host Featherwing that I'm using. And I'm using it with the reverse TFT Feather ESP32S3. If I can find one, I don't know if I have one around here, this non-reverse version could be pretty useful for putting on like a doubler or a quadrupler, so that I could add the USB MIDI, or rather the DIN5 MIDI output Featherwing as well, stack up a few things. But that's the host chip that I'm using there. Last week, I think I showed, do I have it here? I think I don't. A RP2040 doing a similar thing. So you've got some options there on how you're doing your hosting. Okay, that is it from me. I will be back next week. In the meantime, check and see on the Discord if we've got a deep dive with Scott. I know he was out, so he may not be doing one this week. He might be back next week. There may also be check the blogs. There may be a Foamy Guy deep dive. Then we'll be back on Tuesday with Product Pick of the Week. On Wednesday, we'll have 3D Hangouts, a show and tell, and I think I'm hosting that one, or maybe it's next week. I can't remember. We have show and tell, though, and Ask an Engineer. After that, there will also be a Desk of Lady Ada at some hacker times, likely, but not promised. Okay, thanks, everyone, for Adafruit Industries. I'm John Park. This has been John Park's Workshop. I will see you next week. Bye-bye.
Thank you.